We present BoundaryNet, a semi-automatic layout segmentation approach. Machine printing imparts structure to modern-era paper documents. Handwritten documents have dense and comparatively more complex layout segmentation. In this work, we focus on classical handwritten historical documents. Fully automatic approaches for layout segmentation produce reasonable-looking but imprecise region boundaries for handwritten documents. Predicted boundaries often result in improperly enclosed regions. Our semi-automatic approach takes region bounding box as input and predicts boundary polygon as output. Importantly, BoundaryNet can handle variable-sized images without any need for resizing. In the first stage, the variable-sized input image is processed by an attention-based fully convolutional network to obtain a region mask and a class label. The first part of the backbone contains a series of residual blocks to obtain progressively refined feature representations. The second part of the backbone contains a series of skip attentional guidance blocks. Each block produces increasingly compressed feature representations of its input. Output from immediate earlier SAG block is fused with skip features originating from a lower-level residual block layer. This fusion is modulated via an attention mechanism. No spatial downsampling or upsampling is utilized. Doing so enables crucial boundary information to be preserved. Features from the last residual block are fed to region classifier subnetwork, which predicts the associated region class. The adaptive average pooling block within the subnetwork ensures a fixed dimensional output despite varying input dimensions. The final set of features generated by skip connection-based attentional guidance are provided to the mask decoder network, which outputs a region mask binary map. A fast marching distance map is used to guide the region mask optimization to be more boundary aware. The map is used along with per pixel class weighted binary focal loss to improve robustness. Overall, our choices within the MCNN encourage the generation of good initial boundary estimates. Such estimates decrease the task complexity for subsequent boundary refinement tasks. A series of morphological operations are applied to the region mask to obtain the initial estimate of boundary polygon. The pixel predictions in the output from mask decoder branch are thresholded to obtain an initial estimate of the region mask. Centroids of largest connected components are joined by a line whose height is adapted based on original image height. A B-spline representation of mask contour is further computed to obtain a smooth representation. Locations are uniformly sampled along the B-spline contour curve to obtain the initial set of region boundary points. Our anchor graph convolutional network processes the boundary estimate points as a graph and iteratively refines the point locations. The nodes in the graph that is input to anchor GCN consist of sampled points on the mask contour. The 2D position and the appropriate skip attention backbone feature are used as node features. Each node is connected to its 10-hop mask contour neighbors. The boundary estimates are refined via 2 GCN and 6 residual GCN blocks. The fully connected layer at N predicts shifts in XY locations of initial boundary points. We source the region data and annotations from Indescapes, a large-scale historical manuscript dataset. We use a boundary-centric Hausdorff distance to optimize anchor GCN parameters. We also use Hausdorff distance as the evaluation metric. BoundaryNet outperforms strong semi-automatic baselines. In particular, it has extremely good performance for the most common region class, character line segment. Here are some results for various types of regions. Some page-level qualitative results. Note that BoundaryNet can tackle various kinds of manuscripts in their regions. A visual illustration of BoundaryNet's superior quality boundaries compared to other baseline approaches. BoundaryNet's boundary predictions are more accurate than fully automatic methods. In particular, note that BoundaryNet predictions enclose text lines in a proper and complete manner. An example comparing BoundaryNet with a fully automatic instance segmentation method. A comparison with Palmyra, a state-of-the-art fully automatic deep deformable network for document layout instance segmentation. BoundaryNet works for non-Indic documents too. Here are outputs on Arabic and Hebrew historical manuscripts. And on a Southeast Asian palm leaf manuscript. When deployed for annotation, a timing analysis revealed that BoundaryNet reduces overall annotation time, including time for correction. BoundaryNet's effective annotation time is smaller than even fully automatic approaches due to the high quality of boundaries generated by the approach. Code, pre-trained models and an interactive viewer for data and predictions are available at the URL shown. Thanks for listening.